Hello, I am going to talk about acids and bases. My prompt was to use the definition of acids and bases to distinguish between strong and weak acids and bases, the equilibrium relationships among them, and the aqueous properties of their salts. So first I am going to define an acid. An acid is a substance that donates hydrogen ions, which is H+, when dissolved in water here. Awesome. A strong acid, it's under the acid column, strong acid, is one that completely dissociates or breaks apart, if you will, in water. And what I mean by completely dissociates, I mean into ions here. Sorry about that. So it's going to completely dissociate into ions in water. An example equation of this, I'm going to focus on one of the main strong acids that we had to memorize in Gen Chem 1, which is hydrochloric acid. Here's this equation here. One thing to note is this arrow that I used showing that the reaction goes one way because the hydrochloric acid is completely separating into both hydrogen ions and chloride ions. So this is quite the strong acid. Now we're going to talk about weak acids. So as you can imagine, they only partially dissociate into ions in water. Awesome. An example of this would be acetic acid. So I'll write that here. Here's our acetic acid. Look at this arrow. Nice. It's really important for weak acids, that equilibrium arrow there. This double arrow is showing that this reaction is reversible, but we can see that the acetic acid breaks into these hydrogen ions and acetate ions, but we can see that these ions can go back together to form acetic acid again. And that's why we have the equilibrium arrow, where both the forward and reverse reactions are happening at the same rate. Since it's at equilibrium, weak acids don't fully dissociate. Most of the acid stays intact, as we can see here, very much compared to this. I mean, come on. But we can measure how well a weak acid dissociates, and that is from our Ka, or the acid dissociation constant. A small Ka means, the small Ka is showing a weaker acid, and a large Ka is showing a stronger weak acid. Salts formed, going into the salts formed from the strong acids and strong bases are usually neutral, but the salts from weak acids or bases can make the solution acidic or basic. I think one thing that really, when first learning in Gen Chem 1 about acids or weak acids, and weak acids and strong acids specifically, is it just kind of sounds like one's more diluted of each other, like kind of thinking about concentration in that sense. Yeah, not the case as we've seen here. But now let's get into bases. So kind of same thing here, but a little different. A base produces hydroxide ions, this guy here, and water, and it accepts H+ ions. Nice. An example of a strong base, and same idea with strong bases and strong acids, it is fully breaking apart in water. So an example of that would be this here, Na, yep. As we can see, again, all of this is turning into ions. So that is why it is not in equilibrium, it's going one way. And same idea with a weak base, only partially dissociating. So, example of this here, ammonia is a good one. Again, that equilibrium constant for this as well. All right, we are accepting hydrogen ions from water, which forms this here. And like we talked about earlier, these two can form and make this again. That's why it's in equilibrium and it goes both ways. But just like we talked about Ka, we also have a base dissociation constant, which is Kb, and similarly, a large Kb is a stronger base, kind of easy to remember, and a small Kb constant is a weaker base. Yeah, that's all, folks.